Hello, welcome everyone. Welcome back to my channel. Today we are doing surface area and volume of cylinder. But before that, I'm running GCSE classes for all subjects at just £6 per hour. And if you are looking for any subject for any year from year 1 to year 13, if you need to book a free demo, you just need to email us at exactacademy@gmail.com. If you want to access the free worksheets, they are available at exactacademy.com. Also, we have the mock papers and they are highly affordable. So let me start with our topic, which is the surface area and the volume of cylinders. To understand it, let me start with what is a cylinder. When we were doing cones, I explained you when there is a right triangle and if you fix its one side and move it with other side, mainly from the side of hypotenuse, and if you can say rotate it about its own axis, the 3D figure that will generate is a cone. Now, if you have a rectangle, let me show you it here. This is basically a rectangle. You just need to fix this end. You have just fixed it. You just need to pick this point and rotate it about this fixed axis. The 3D figure that will be formed is your cylinder. So this is actually this 3D figure. You can clearly see there are three surfaces of the cylinder: the top one, the bottom one, and this middle one. The top one is a circle. If you see this one, the upper one is a circle, the bottom one is a circle, and the middle one is a curved surface. So this is basically your three-dimensional figure, which is a cylinder. It has two parameters, radius and height. This is radius, which is radius of the cylinder or of the upper circle, and the height is the total vertical height of the cylinder. Now let me see how can we calculate the total surface area and volume of this cylinder. Now, if I open the cylinder, this curved part only, let's say this is not a solid cylinder, instead it's a hollow cylinder. If you open this one, this curved part, it will be actually a rectangle. So when you open this one, the cylinder, it's curved part. When you open it, it's actually a rectangle. So you can understand this you can think it. There is a rectangle. When you roll it, it will become a cylindrical, right? It's the same thing. And it's very easy to calculate the area of this rectangle. Doesn't matter how you are shaping it, the area will remain exactly the same. So when it's a rectangle or a curved surface, doesn't matter, the area will remain exactly the same. So it's much easier to calculate the area of this rectangle, which is length times width. Now width is nothing, it's height, right? Think you are making it or you are converting it into a rectangle, so height will remain exactly the same. Height is nothing but your width. So I can write this as h. And this one, because this bottom part has now become a circle, obviously you just need to think that you have already turned this one, and then it will become a circle. So this is nothing but now this length is equals to circumference of a circle, and the formula to calculate circumference of a circle is 2 pi r. So area of this rectangle is length times width, which is 2 pi r h. So this is the formula to calculate area of the curved surface. Now see this one, we have three different surfaces. This is the top surface, this is the bottom surface, and curved surface is the middle one. This one is clearly we have calculated as 2 pi r h. Upper one and the bottom one are circles with radius r, so its area is pi r squared. So total surface area is adding the areas of all three surfaces, which is 2 pi r h plus pi r squared plus pi r squared, which is 2 pi r h plus 2 pi r squared. Taking out 2 pi r as common, h plus r is your final formula to calculate total surface area. Now, if in the question it's mentioned that you have to calculate the curved surface area, then you have to use this formula only, because this is the formula to calculate only curved surface. Now, volume is the space covered by the particular 3D object. If I draw a cylinder, it's actually a circle. There is a circle, and if you stack a circle, that means you have to stack so many circles over each other till the height of h. So the volume will become, so if I'll stack the circles over each other, ultimately I'll get a cylinder. So the volume of cylinder is area of the circle pi r squared, and it has been stacked over each other up till the height of h, so it's h, and this is the final volume of a cylinder. So we now know that the curved surface area of a cylinder is 2 pi r h, and the total surface area is 2 pi r h plus 2 pi r squared, whereas the area volume of the cylinder is pi r squared h. Let me do some questions. Question 1 says, calculate the curved surface area and the volume of the cylinder, where the radius is 4 centimeters and height is 20 centimeters. So curved surface area is 2 pi r h. So 2 times pi, radius is 4 and height is 20. This will be 160 pi centimeters squared is the curved surface area. If I'll substitute the value of pi, I'll get the answer as, so it's finally 502.65 centimeters squared. Now question 2 says, the curved surface area of a cylinder is 800 pi, then find the product of the radius and the height of the cylinder. So, because it's given the curved surface area of a cylinder, we have to use the formula. We know the formula is 2 pi r h, and this is equals to 800 pi. I just need to divide both the sides by 2 pi. It will give me RH is equals to 400. And this is your answer, because they're asking you to give the product of radius and height of the cylinder. Now calculate the volume in terms of h. So volume of a cylinder is pi r squared h. And because they are asking in terms of h, that means your final answer should contain only h, not another dimension, okay? Not another variable. If it's given is in terms of h, that doesn't mean only h. There can be any constant. Pi is a constant, it can be there. 2, number 3, 4, 5, it can be. But another variable is not acceptable in this case. So we have to remove r, or I have to find the value of r in terms of h. So I can use the first equation, the first one, this one. From part 1, I can say r times h here is 400. So r is 400 over h. I can substitute this value. So now v is equals to pi times r is 400 over h whole squared times h. This is 160000. Square of 400 is 160,000 times pi over h squared over h. So final answer is 160,000 pi over h, and that's your volume in terms of h. Part 3 says, if the ratio of the radius to height is 1:4, find the total surface area of this cylinder. It says if the ratio of radius to height is 1:4, so I can say that if your radius is x, then height would be 4x. That's the meaning. When you convert the ratios into the number, you just need to multiply it with x. So radius will become x and height will become 4x. Now this value I have to substitute in place of this, because this will help me in getting the value of x, and so I can get the value of r and h, and then it would be easier for us to calculate the total surface area. So because we know r is equals to 400 over h, I can substitute r as x and h as 4x. So this will give me x squared is equals to 100 and x is thus equals to 10. We now know that the value of x is 10. I can calculate the value of r and h. So I'm just running out of the space. So radius is, because we have calculated the value of x as 10 and r was x and h was 4x. So I can say r is 10 centimeters and h is 40 centimeters. Now they're asking us to calculate total surface area. So total surface area of a cylinder is 2 pi RH plus 2 pi r squared. So this will be 2 pi times r is 10 and h is 40 plus 2 pi and squared of r is 10 squared. This will give me 800 pi plus 200 pi. Finally, it's 1000 pi. Either I can leave this as it is or I can substitute the value of pi. This will give me my final answer as 3141.59 centimeter cubed. So this is basically our final answer for total surface area. Now, moving on to the next part, which says, this is the next question basically. Question 3 says, a cone of vertical height 10 centimeters and base radius 3 centimeters. So up there we have the basic diagram of this question. A cone of vertical height 10 centimeter and base radius 3 centimeter is placed inside a cylinder of radius 3 centimeters and vertical height 10 centimeters. Then water is filled in the cylinder and it occupies the space left by the cone in the cylinder. Then this water is transferred to a cuboidal vessel of length 22 centimeters and width 20 centimeters. We have to find the height up to which the cuboidal vessel will be filled. See, first of all, let me understand what this question is asking. There is a cylinder and the radius is r and height is h. Just look at the diagram. It will give you a basic idea of this. Then a cone with the same radius. That means the cylinder and the cone, they both have exactly the same radius. Okay, so they are overlapping with each other, leaving no space. And the height is also exactly the same. But obviously the cone, the space covered by the cone is much lesser than the space covered by the cylinder. So there must be some remaining space. This is that remaining space here. This is an empty space. What's mentioned here is this is a whole solid cylinder, solid cone. When you pour water inside the cylinder, definitely water will take this empty space because the cone is solid, so cone cannot take the water. So water will be filled only in that space. Then this water, whatever be the volume of that water, once the whole cylinder got filled, the volume of that whole water will be transferred to a cuboidal vessel, and the length of that cuboidal vessel is 22 centimeters and width is 20 centimeters. So that's given, and then the whole water will be filled in that cuboidal vessel and we have to calculate what will be the height of that water. This is the question. So that means we first have to calculate the space, you can say the empty space covered by the water. So for that, first we will calculate the volume of cylinder and I need to subtract the volume of cone. Obviously, when I'll subtract it, I'll get that empty space. So we know that volume of cylinder is pi r squared h. And a cone having the same radius and same height as that of a cylinder always has the volume 1/3 the volume of a cylinder. That means volume of cone is pi r squared h over 3. Now, obviously, the empty space is the subtraction of both these volumes. So, volume of empty space pi r squared h minus pi r squared h over 3, which is 2 over 3 pi r squared h. That's the volume of the empty space. We just need to substitute the value of r and h to get the volume of the empty surface. So finally, volume of empty surface is, let me just write it here, volume of empty surface, I just need to substitute the value. R is given as 3 centimeters and height is 10 centimeters. So it's pi times 3 squared times 10. And this is finally equals to 188.49 centimeter cubed. Now this volume of water is transferred to a cuboidal vessel. And this cuboidal vessel has length 22 centimeters, that's written here, and width 20 centimeters. So obviously that means the volume of water taken by the vessel, obviously I mean the volume of water in the vessel is definitely equals to the volume of water in the cylinder because it's the same water. So I can say that volume of cuboidal vessel, or simple, I can equate the volume of cuboidal vessel is length times width times height, let's say b, h1 is equals to 188.49. From here I can calculate h1 as, this height is 0.424 centimeters. It's very small basically. So this is the height when you pour it in that cuboidal vessel, that will be the height taken by the water. Now the part B says, if the height of the vessel is 5 centimeters, will the water overflow? No, definitely. The height of the vessel is already 5 centimeters and height taken up by the water is just 0.42. It's a very small height. So obviously there will be no overflow of the water. So that's it for today. That was all about the volume of cylinder. In the next class, we'll be doing the worksheet on volume and surface area of cylinder. Same, if you wish to book a free demo, just email us at exactacademy@gmail.com. My tutors are really highly experienced. They are very good. And you know what? There is a lot difference between teaching online one-to-one and getting the tutoring from the YouTube. Obviously, because that interaction you cannot experience, because I'm not talking to you at this point of time. I'm just explaining this. But in one-on-one or in online classes, if the student asks me any question, I repeat 100 times until he understands perfectly. So that's a whole different experience, and there you can learn so many things, so many new things, because here, because time is limited, my the knowledge that I can provide you is also limited. But in like in your online classes, you can get more knowledge, much more deeper, and you can ask many questions, and in groups you can avail the great advantage. Why? Because the groups are pretty small, just like 3-4 students in a class, but everyone has a different mind. They have different questions in their mind, and when they ask and when I answer them, the other can gain that. So if you wish to book online class free demo, just email us at exactacademy@gmail.com. So that's it for today. Bye. Have a great day.